Okay, so we're right on the edge of a world where AI can write its own code. I mean, think about that. It's an incredible leap forward, but it also brings up a massive question. How on earth do we trust it? Today, we're going to break down a new framework for test-driven development that's a blueprint for exactly that. How humans and AI can build really complex software together, safely and reliably.
And this really is the central challenge, isn't it? As AI starts to take on the role of a software developer, how do we guarantee that its work is secure, that it's correct, that it actually does what we need it to do? Trust is everything here. Without a solid system to verify the AI's code, we're basically just closing our eyes and hoping for the best. So this is the solution we're looking at today, a framework for test-driven development, or TDD, but one that's built specifically for AI. It maps out a really structured partnership. You can see it starts with a human architect, then flows to an AI developer, goes through a super strict quality check, and finally, the output becomes a flexible software product. It's the whole blueprint for collaboration.
Let's start right at the beginning, because the whole process is anchored by a human. In this system, they're called the dev/test, but honestly, it's easier to think of them as the project's architect. And they aren't just giving the AI some vague ideas. No, they are meticulously defining the exact blueprint the AI has to follow. The human architect provides three absolutely critical inputs. First up is the test spec, which basically defines the rules of the game, exactly how the software should act. Next, you've got the test data. Think of this as the raw material the software is going to have to work with. And finally, you have the acceptance tests. This is the final exam. It's what defines done, and it's the test the AI's code must pass to be considered a success. All right, so with that detailed blueprint in hand, we can bring in our builder, the AI developer. Now, this isn't some magical black box just making creative guesses. It's better to think of it as a hyper-efficient, super focused tool that takes the human's precise instructions and just gets to work, turning those specs into actual artifacts. So the AI's main job is to generate what's called a software artifact. That's the first version of the code. But what's really crucial here is that it doesn't just write the code for the feature. It also writes the tests to prove that its own code works, all based on those initial specs from the human architect. So the AI has built something, but can we actually trust it? Well, this brings us to what is, frankly, the most critical part of this whole framework, the quality gate. Before that software artifact can go anywhere near the final product, it has to go through a rigorous, totally independent inspection. This is where trust is truly earned. The decision at this stage is dead simple. It's a binary choice, go or no go. There is no, well, it's kind of good enough. The artifact either meets every single quality standard without exception, or it's rejected and sent back to the drawing board. It's an absolutely non-negotiable checkpoint. So what's actually being checked in this tough inspection? It comes down to three key areas. First, independent security audits are hunting for any vulnerabilities. Second, tests coverage analysis make sure the code is thoroughly tested, leaving no blind spots. And third, code quality analysis checks that the code is well-written, easy to maintain, and follows best practices. Only if it passes all three with flying colors does it get the go. Once an artifact passes that intense quality gate, it officially becomes a trusted module, ready to be plugged into the larger software product. But the real key here is how it gets integrated. We're not talking about creating one giant, tangled piece of code. The strategic genius here is this modular approach. Traditional monolithic software is kind of like a Jenga tower. If you try to pull out one wrong piece, the whole thing can come crashing down. A modular product, on the other hand, is more like a set of Legos. Each piece is independent. You can swap one out, add a new one, or remove one without breaking the entire structure. This just dramatically lowers your risk and makes everything way more flexible. This modularity gives the stakeholders, the people in charge, incredible power. Need to upgrade a feature? No problem. Just swap out the old module for a new, AI-generated one that's already passed the quality gate. Want to add brand new functionality? Just integrate a new module. And what if an update causes a problem? No worries. You can instantly roll back to the previous version of that one specific module without disrupting anything else. It's a game changer. So let's just zoom out and look at the whole picture one more time. The human architect defines the problem with very specific tests. The AI builds a solution. A super strict quality gate makes sure that solution is trustworthy. And the final result is a flexible, modular product built from these verified components. It's a complete end-to-end system for building better, safer software with AI.
And that right there is the crucial point. This framework isn't designed to make human developers obsolete. Not at all. It's designed to give them a powerful new collaborator, one that can do the heavy lifting of generating code while the human gets to focus on the big picture, the architecture, the strategy, and making sure the final product is exactly what it needs to be. It's really about leveraging the best of both worlds. Which, of course, leaves us with a final, pretty big thought. As AI gets more and more capable, frameworks like this one that put human intention and rigorous verification right at the center of the process, they might be more than just a smart way to code. They might just be the key to ensuring that the future AI helps us build is one that we can all actually trust.